So here we're going to figure out the pH of a strong base. And typically what we know is that if we know the concentration of the strong base, we should know what the concentration of our OH minus is. But they decided to play a little bit dirty here because they gave us barium hydroxide. And if you realize barium hydroxide is BaOH in parentheses 2. Now, typically what I tell you is whenever we're starting off a problem, we want to write a reaction for it, we take it and throw it into water. But if you're dealing with the hydroxide, it gets kind of uglyish. So what we do is we just treat this as an aqueous solution, and all we do is we break it apart like this. Now, I'm writing a single arrow right here. In reality, you may see sometimes things written like this because that's equilibrium, but this is a strong base. Remember one strong cal bear from the solubility rules video? And so if I break this apart, I'm going to end up with Ba2 plus 2 OH minus. These are aqueous. Now, here's what we do know. If we know what our initial concentration is here, we know that for every one of these, we're going to get one of these and two of these. And that's what we really care about, because if we can figure out the OH minus concentration, then we can figure out the POH and then figure out the pH. So it's a kind of a multi-step problem. So if I were setting it up, I would say something like this. First, figure out the molarity, then figure out the equation ratio. That would be the 2-to-1. And then figure out the OH minus concentration, and then figure out the POH, and then figure out the pH. Seems a lot more complicated than it actually is, but they didn't do us any favors here because they could have started us off and they could have given us the concentration. Oops, did not want to do that. They could have given us the concentration of this barium hydroxide, but instead they gave us the milligrams and they gave us the milliliters. That's kind of meanish, but we've dealt with them before, so let's deal with them again. And so what are we going to do? We're going to start off with the amount that they give us here of 236 milligrams of the BaOH in parentheses 2. I'm going to not write this anymore just because my hands are growing tired, but we want to convert that to grams and then to moles, because ultimately we need to figure out what our molarity is right here. And remember, our formula for molarity is always moles divided by volume. So we're going to try two things. We're going to try first to get the moles from the milligrams. And the second thing, we're going to get our volume from our milliliters. And when we divide that, we're going to get our molarity, which we can plug into our overall equation. So when we're working on this right now, what do we need? Well, we want to get this to grams. So we're going to go 1,000 grams for every 1,000 milligrams for every 1 gram. That gets us 2 milligrams. And then what we're going to do is we're going to look up the molar mass of this monstrosity. And from the benefit of having already done this off screen, I know that there is 171.341 grams of this for every 1 mole of the BaOH in parentheses 2. Now, this right here may seem like a lot of sig figs, but let's keep as many sig figs as we can, and we'll only change that at the very end. And again, from having done this off screen, we end up with 0.00137774 moles of the BaOH in parentheses 2. So if we know our moles right now, we just have to convert our volume right here to liters so we can plug it into this equation. So because we are good with our conversions and we know that we have 100 milliliters, couldn't we just go ahead and go 100 milliliters? Isn't that really 0.100 liters? Now they put a decimal in this, so I want to keep track. So if we go back to our formula, molarity equals moles divided by volume, we can put our moles, this number right here, and we can put this number right here down below. So I'm going to go ahead and do that, and then we're going to write on the top 0.00137774. You, by the way, could have done this with scientific notation. It would have worked out just as well. 0.100 liters, and when you do the math on that, you end up with 0.0137774 molar. Now this is the molarity of our BaOH in parentheses 2. So this is important. We're going to come back up to our equation. This right here, this number right here, this 0.013774, we're going to put this number right here as in our initial amount. So 0.013774. That's our initial amount of this. Now, since this is not an ice problem, I'm just going to go initial and final. Initially, I have this, and I have 0 of this and 0 of this. Now, this is where it's really important. At my endpoint, I'm going to have 0 of this, but when I have 0.013774 molar of this, but this is where this becomes really important. When I have 2 times 0.13774 here. Now, why does that matter? Because if I multiply this out, I'm going to end up with my OH minus, and mind you, this is an OH minus concentration, 2 times this number, and when I multiply it out, I'm going to end up with my OH minus concentration is equal to 0.027548 molar. Now, they didn't ask me for my OH minus concentration. They didn't even ask me for my POH concentration. They asked me for the pH. So how do we solve for pH? Well, we can take this number right here, and we can do one of 2 ways. Either A, we can go from OH to H plus, and then to pH by taking the negative log. Or we can take the H plus times OH minus is equal to 1.0 times 10 to the negative 14. And once we figure out the H plus concentration, we can then take the negative log of that. It really depends what you feel the most comfortable with. If you, and I don't know exactly how they did it in ALEKS, but I'm going to do it OH minus concentration times H plus concentration equals 1.0 times 10 to the negative 14. And we plug this value in, H plus concentration is equal to 1.0 times 10 to the negative, that's a 14, divided by 0.02748 molar. We're going to end up with our H plus concentration being equal to 3.6663 times 10 to the negative 13. So again, I probably wouldn't have done it this way. I probably would have just gone straight ahead and taken the negative log of this and then subtracted from 14. But now if I want to figure out the pH, I'm going to go pH is equal to the negative log of 3.6663 times 10 to the negative 13. And when I do that, my final pH is going to be equal to 12.43577, and so on and so on. But remember, if we take a look back at our original problem, they gave us 3 significant figures right here. So that means my answer has to have 3 significant figures. And remember, we start counting the significant figures after the decimal place when we're dealing with pH. So my final answer is going to be pH is equal to 12.436. Again, it seems like a lot of work, but in essence, all we ended up doing is figuring out the molarity from these 2 pieces of information. And once we had the molarity, the hardest part was realizing there's 2 of these OHs for whatever the molarity is here. And then it becomes just a regular, can you convert between H plus and OH minus, etc. So hopefully this is